Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 12B. Myself, Ashutosh Goel, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025, Goa, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 17 July in Goa, India, and the virtual event is being held through Zoom from 17 to 19 July 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations, and each presenter will be given 10 minutes for the presentation and 2 minutes for question and answer. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Dr. Kirti Vanjale. Dr. Kirti Vanjale is currently working as an associate professor in the Department of Computer Science in Vishwakarma Institute of Technology. She has over 14 years of teaching experience. She has presented papers in many national and international conferences and journals. Her research areas are wireless sensor network, artificial intelligence, Internet of Things, and image processing.
Thank you for the introduction, Ashutosh.
Thank you, ma'am. Now, without further ado, let's start with the first presenter of the day. I would like to call upon Ma'am Meena Rani to present a paper on the title, A Comprehensive Review of Techniques for Image Forgery Detection and Localization. Do we have you here with us, ma'am?
Yeah, sure, sir.
You may start presenting your screen, ma'am.
Good afternoon, everyone. I hope you are all doing well. My name is Meena Rani, and I am a student at IEC University. Thank you for all joining this session. Today, I am going to present on the topic a comprehensive review of technique for image forgery detection and localization. This presentation will focus to develop a robust and scalable model for passive image forgery detection and localization using conventional neural networks. The outcome will be the deep learning based approach significantly outperform traditional image forgery detection technique in terms of both accuracy and localization ability. So let's begin with a quick overview of this topic. A comprehensive review of technique for image forgery detection and localization. Abstract. The exponential growth of smart devices and advanced image editing tool has made detecting and localizing image forgery critical for ensuring digital content integrity. This paper focuses on developing a robust and scalable model for passive image forgery detection using conventional neural networks. Compared to traditional technique, the deep learning based approach shows significant improvement in detecting complex forgery, including splicing and copy move manipulations. Keywords are here: image forgery detection, conventional neural networks, passive forgery detection, digital forensic, and deep learning. Introduction. Digital image of forgery have become much more common as a result of exponential rise of smart devices and the quick development of image processing software. With billions of sensor-enabled objects and high-quality camera integrated into everyday devices, the creation and distribution of manipulated images have become more accessible than ever. Platforms like social media and professional environment rely heavily on visual data, which has further fueled the widespread dimension of altered content. While these technology have enabled unpretended communication and sharing, they have also introduced significant risk, including the manipulations of image for unethical purpose, such as spreading false information, political propaganda, or financial fraud. Digital image forgery detection have two types. One is active forgery detection and another is passive forgery detection. Active forgery detection require prior insertion of verification data into the image during creation, and passive image forgery detection analyze digital image without relying on prior embedded information. Literature review. This literature review highlights key developments in both area, identify gaps and position the current study within the research landscape. Here is the author, their technology, feature, model and result. First is the Ganad and Parsi introduce a unit model optimized with the Grosvenor algorithm for detecting image forgery on social media. Results show superior performance compared to traditional machine learning based method. Geong proposed a CMCF, a context multi-scale cross-fusion network or copy move forgery detection. This study demonstrates significant improvement in forgery localization accuracy. Next author is Janadi. This study review various architectures including CNN, GNN, transformer-based model. It highlighted challenges such as data sets, limitation, and generalities. Next is Guilaro. Proposed to offer a deep learning framework all-round clue for trustworthy image forgery detection. The study demonstrated the effectiveness of TOEFL in various manipulation scenario. Next author is Meher Jardi, and technology used deep learning CNN GN transformer. Next is the core and use technology CNN features copy move forgery detection model CNN based framework, and result of a paper is high accuracy need of generalization in future model. Next is Chinamma and Madhushri feature extraction classification techniques, and the model is used nothing, and the result of paper is emphasis explanation AI and hybrid model for future research, and so on. Next is methodology and techniques. Deep learning enabled passive forgery detection. This method employ conventional neural network to detect anomalies such as unnatural transition, noise, inconsistent, and compression artifacts. Advanced CNN architecture have demonstrated high accuracy in identifying forgery type like copy move, splicing, retouching, manipulation, proving the robustness in diverse real-world scenario. Training and optimization. Training CNN on data sets like CASIAS and MICCF220 ensure exposure to various manipulations technique like transfer learning data, data augmentation, and resilience against counter forensic method. Are conducted using metrics such as precision, recall, and intersection over union for assessing detection and localization accuracy. Data sets are used here. CASIA1 dataset. The CASIA1 dataset developed by Chinese Academy of Science, and it contains a diverse collections of both original and tempered image created through splicing and technique. Next is MICCF220 datasets provided by the Media Integration and Communication Center at the University of Florence, and is designed specially for evaluating copy move forgery detection algorithm. Now compare analytic technique, that is conventional technique, and deep learning technique to better contextualize the strength and limitation of traditional and modern forgery detection approach. Let's see the comparison between both techniques. criteria, detection basis. In conventional technique, handcrafted feature like noise, inconsistency, and in deep learning, automatically learned feature using CNN, GAN, and transformer. Next is forgery type detected in conventional primary splicing and copy move manipulations. In deep learning, splicing, copy move, retouching, and deepfake. Real-time applicability possible with optimizing algorithm, challenging but possible in deep learning. Robustness to post-processing in conventional low to moderate, but in deep learning high. Localization accuracy limited in conventional but high in deep learning. Generalization capability, poor generalization in conventional but high in strong. Computational efficiency lower in conventional technique but high in deep learning technique. Now, application and implication. Application: media integrity CNN based forgery detection tool validate the authenticity of visual content across social media platform and news outlet. Law enforcement: forgery detection enhance digital forensic by authenticating evidence such as surveillance footage and crime scene footage. Photographs. These tools are crucial for identifying manipulating content in legal and counterterrorism investigation. Implication: societal impact and legal technological advancement. Challenges: despite notable progress in deep learning based image forgery detection, several critical challenges remains. The gross sophisticated of forgery, especially those generated by GN, make them visually indistinguishable to both human and detection systems. Additionally, accurately localization tampered region remain the challenge, particularly when dealing with minimum or simultaneously blended alteration. Future direction. Now, in future direction, research should focus on improving the robustness of image forgery detection system against evolving manipulation technique and adversarial attack. Exploring the hybrid deep learning method like combining CNN with transformer or attention mechanism can enhance both detection accuracy and tempering localization. Now I want to come on conclusion. An image forgery detection has become essential for maintaining the integrity of digital content across various sectors. Deep learning technique, particularly CNN and data sets, have shown strong potential in detecting common manipulations such as splicing and copy move. However, challenges remain, including susceptibility to adversarial attack, limited data set diversity, and high computational demands. Addressing these issues, the more resilient model, richer data set, and efficient hybrid approach will pave the way of scalable real-time solution capable of countering increasingly sophisticated forgery.
Thank you for
So in last, I want to represent results of this research. According to me, the deep learning based approach significantly outperformed traditional image forgery detection technique in terms of both accuracy and localization ability. The model effectively detected complex manipulations such as splicing and copy move, demonstrated strong generalization across diverse data sets, proving its scalability and robustness, highlighting the potential of real-world applications in digital forensic, media verification, and cybersecurity. And these are now references. Thank you. Now you can ask questions.
thank you for presentation, ma'am. Are there any questions?
Yeah, I have a question. So this is Dr. Kirti Vanjale. Ma'am, you said talked about certain data sets. So I just want to know what was the size of the data set. I mean, how many images were there, and were the images with annotations or without annotations?
Can you
Hello?
repeat? Hello?
Yeah, my question is about data set. how many images were there in the data set, both the data sets, and was the all images were in the annotations or without annotations? I mean, are
These
they
data set
labeled
are
or
widely used in CASSI one contain realistic splicing forgery with clear ground truth marks, high resolution, copy move manipulated.
I'm asking about size in the sense how many images were there? Thousands, hundreds. Do you know that?
Hello.
How many images were there?
Size around is hello.
Yeah, I can hear you.
Yeah, size around is 10440.
I am not asking about size, I am asking about number of images in the data set. Like after that, how many of you, how many images you have used for training and testing purpose? Are you aware about that?
Yeah, ma'am. I used a number of images, not a particular counting, but I have tried in so many images.
Okay. Okay, thank you. Thank you from my side.
Okay, ma'am.
Thank you for your presentation, ma'am. Now moving on to our next presenter, I would like to invite Ma'am Kritika to present a paper on the title Blockchain in Public Distribution System. Do we have it
Thank
here
you
with
so
us, ma'am?
much. Yes, I'm here.
Okay, ma'am. You may start
Just a
presenting.
second.
Sure.
Sure, may I leave or I have to join this also?
Ma'am, I request you to stay back to the end of the meeting because we will be taking a virtual snapshot of the whole conference.
Sorry, I can't audible.
Ma'am, I request you to wait till the end of the meeting as we will be taking a virtual snapshot of the whole conference.
Okay, sure, sir. No issue.
Okay, so good afternoon, everyone. I am Kritika Benjwal, and along with my teammates Rishika Agrawal and Rashi Gupta, we are presenting our research on blockchain in public distribution system under the guidance of Professor Dinesh Kumar Sani at Manipal University, Jaipur. Food security remains a global concern, especially for vulnerable populations. India's public distribution system, or PDS, is one of the largest mechanisms designed to ensure food security. However, PDS suffers from serious inefficiencies like diversion of food grains, fake beneficiaries, and inconsistent records. Our paper identifies these loopholes and proposes a blockchain based framework from other countries to tackle them. Global food security initiatives. Let's first understand how other countries address food security. The US uses systems like SNAP and WIC with social security numbers to control fraud. The UK uses universal credit and community food support. Brazil's Farm Zero combines subsidies with community kitchens. Japan and the European Union control prices and provide direct food aid. These systems share a common goal: transparent and targeted food support, something India still struggles with in its PDS. India's PDS spans over 5,35,000 fair price shops and reaches more than 231 million people. It operates through schemes like TPDS and AAY, distributing essentials like rice, wheat, and kerosene. But the key challenges still remain, like leakages and black marketing, fake ration cards and ghost beneficiaries, inefficient logistics and bribery, and outdated biometric and identity verification systems. These led to widespread exclusion of the deserving poor and massive resource wastage. PDS operational stages and anomalies. Our research breaks down the PDS into 8 stages from procurement to monitoring. Every stage, from storage to pricing, shows gaps. Poor warehouse conditions, fake procurement records, postcards at distribution level, corrupt middlemen, and limited technological integration. These systematic issues call for tamper-proof, transparent solution, and that's where blockchain comes in. Blockchain is a decentralized ledger system, meaning data can't be changed once written. We compare public, private, and consortium blockchains. For PDS, a consortium blockchain is most suitable, where selected participants like government bodies, warehouses, and ration shop owners form the network. We propose using Hyperledger Fabric, which is a modular and supports permissioned access. Blockchain in PDS has 4 core components: movement of grains, storage, quality control, and final distribution. All stakeholders, from the Food Corporation of India to fair price shops, are nodes in the network. Smart contracts automate processes like procurement, transport, and allocation. Every transaction is validated and recorded securely in blocks, ensuring traceability and transparency. The proposed architecture includes beneficiaries authenticated with Aadhaar-linked biometrics, smart contracts for tracking grain movement, digital certificates for participants issued by a central authority, and cloud storage to manage heavy transaction data. This system provides a real-time tracking from procurement to delivery, reducing scope for fraud. Despite its promises, the current framework has limitations. It cannot verify if the ration card holder is genuine. Biometric updates are not automated, leading to authentication issues. Ration cards of deceased individuals are still misused. Unidentified or unaware individuals remain excluded from benefits. So while blockchain improves transparency, more robust identity and outreach mechanisms are still needed. Future improvements could include smart ration cards with QR or RFID, mobile apps for real-time entitlement tracking, decentralized procurement like Brazil's local sourcing model, involving NGOs and SHGs for awareness and accountability, and integrating AI and IoT for real-time monitoring. Private sector partnerships can help modernize logistics and infrastructure with these additions. India can build a more inclusive, efficient, and tamper-proof PDS. Thank you for your attention. We'd be happy to take any questions.
Since there are no questions, we'll be moving forward with the next presenter. Next, I would like to call upon Ma'am Sandhya to present a paper on the title Design and Analysis of Smart IoT-Based System for Fuel Dispensing. Do we have you here with us, ma'am?
Yes, I am here. I will share my screen. Hope you are able to see my screen.
Yes, ma'am.
Hello, everyone. Good afternoon. I am Sandhya Borkar from D.Y. Patil's RIT College, Navi Mumbai. It's a pleasure to present my research on this platform. The topic is Design and Analysis of Smart IoT-Based System for Fuel Dispensing under the guidance of Dr. Sheetal Patil. Moving ahead. This is the outline that we are going to discuss. Introduction, objectives, literature survey, system overview, working process, design representation, mobile application, performance matrix, benefits, limitations and future scope, conclusion with references. Introduction. The current system available are operated manually, causing longer wait time, manual errors, fuel thefts, and they are not available for 24/7. So With the growing number of vehicles, we have proposed the smart system, which is combination of hardware and software. This system will improve operational efficiency, enhance security, and prevents fraudulent activities also. The main objective of this project is to develop a smart automated fuel station, which is user-friendly and which will help in real-time data monitoring, remote management to minimize manual intervention, eliminate cash handling, and the operational for 24/7. And it will be a safe and secure petroleum business with minimal investment. Here is the literature survey. We have reviewed previous research papers. The slides showing here gives an overview of the existing system and technologies used. In our current work, we aim to overcome the limitations of the earlier system. As I mentioned, the system is a combination of components and technology used to modernize the architecture and to improve system performance, efficiency, and to increase user satisfaction. System overview. As I mentioned, it's a combination of software and hardware. We are using here for identification RFID reader. Raspberry Pi is used for control and communication. Safety purposes and tracking purposes, sensors are used. Python programming used for communication and chatbot for real-time alerts to the users. Here is the presentation, a block diagram system architecture that you can see how RFID reader is communicating with the Raspberry Pi, and Raspberry Pi is actually a central controller over here, and it will communicate with the reader also, with the user also via mobile application, where they will send and receive instructions. And it will control the pump via relay also. Working process. The working process is very simple. As soon as the vehicle will enter the fuel station, the RFID tag available on vehicle is scanned and authenticated. The mobile app prompts the user to enter the fuel amount. Once the second RFID tag near the fuel inlet is scanned, the fuel dispensing begins, and the system will automatically shuts off after reaching the desired quantity. And once the transaction is completed, the complete transaction summary will be shared on the mobile device with the user. This is the pictorial presentation where you can see the RFID components, Raspberry Pi, sensors, and vehicle mobile application. It will help the user with real-time notification, fuel input control, low balance alert, and complete transaction will be available on his mobile application. This is a transaction history. This is an example of transaction, how it will look. It will show date, time, description, quantity, cost, balance available. This is the performance matrix, which compares the traditional system and our proposed system, which shows how it is beneficial to the user. Benefits I have mentioned here. It will enhance operational efficiency, contactless transaction, reduce theft and frauds, minimal power requirement, 24/7 availability. The user can maintain the record digitally. Limitations. There are few limitations, like the system needs a stable internet. And also the tag we are using are a RFID, passive RFID tag, which have a limited reading range. So to overcome all these, in future, we can add offline supports using local server. And for tags, we can use higher frequency tags, like ultra high frequency tags. So that can be implemented in future. And additionally, machine learning can be used to predict fuel needs and maintenance. Blockchain can be used to make transaction more secure and traceable. To conclude, the proposed IoT-based smart system improves efficiency, accuracy, transparency, security. It offers a scalable and user-friendly solution for generals and industrial units also. Here are the few references that we have used. Thank you. Thank you for your attention.
Yes, very good presentation, ma'am.
Thank you.
I just want to know, just go to your system diagram. Can you please?
system architecture, correct, ma'am?
Yeah. Okay. You have used certain sensors, I guess.
Yes,
Somewhere
like
you have
level
mentioned.
sensor and smoke sensor.
Yeah. So I just want to know like which kind of sensors you have used. You said level and smoke sensor. Very
Smoke
good.
sensor, yeah.
And Raspberry Pi you have used. Why why you went for Raspberry Pi? Like
Ma'am,
there are
actually Raspberry Pi, if you want to complete, if I'm sorry if I've disturbed you in between, please.
no issues. Yeah, please go ahead.
Okay. Raspberry Pi we have used because it shows lots of benefits are there with Raspberry Pis. Like it has a SD card with it in Wi-Fi availability is there in the Raspberry Pi, and it is a two-way communication we can do through the Raspberry Pi. The processor is inbuilt, so instead of using multiple things, we can use a Raspberry Pi, which is a board where many things are inbuilt already there, so we don't have to use multiple hardwares. So to avoid those things, Raspberry Pi is used.
Good. Like, is there any other kind of existing application similar to this? Any system
Ma'am, we
similar to this?
have, but they have not used the Raspberry Pi. They have used Arduino, as I mentioned in my system architecture, that they have
Yeah.
used, but there are different components they have used. And the hardware part is more in that case.
Okay. So I'll suggest if possible you can go for patenting your idea.
Okay.
By looking at your applications and at the results that you have shown, I guess this is a very good idea. So I'll suggest you can go for the patent one,
Thank you,
patenting
ma'am.
it.
Thank you so much.
Yeah. Thank you.
Thank you.
Thank you for your presentation, ma'am. Now moving on to our next presenter, I would like to invite Sir Shubham to present his paper on the title Enhanced Deepfake Detection Using Multi-Model Approaches, a Comprehensive Analysis. Do we have you here with us, sir?
Okay, sir. Hello, am I audible?
Yes, sir, you're audible. You may present your screen, sir.
Is my screen visible?
Yes, sir.
Okay. So, good afternoon, all. So, my name is Shubham Dinkardeve. I am final year MTech student at Pimpri Chinchwad College of Engineering, Pune. So, my paper topic name is an enhanced defect detection using multimodal approaches, a comprehensive analysis. So, this is the agenda of my today's presentation. So, first of all, let's start with the introduction. Deepfakes means the manipulated audio, video, or images using the AI or any other tool. So these are the deepfakes. So it has a three categories: image deepfakes, audio deepfakes, and video deepfakes. And it has a many forms like a face surfing, face reenactment, lip syncing, voice cloning, age progression. So these deepfakes are recently in recently these deepfakes have a major attack on the uh, Instagram influencers and YouTube stars. So this is the hot topic to research. So my motivation behind that to preventing misinformation, protecting privacy and security over the media, and prevention of trust in social media. So this is the problem statement of my research. The rapid advancement of AI-generated deepfake poses serious threats. So we need a faster and more reliable deepfake detection system. So this is the literature survey. For this literature survey, I taken the reference from many papers, but I will tell you the in few words what is in this literature survey. Many recent literatures done this done the research on this topic, and they use the many deepfake detection data set majorly available over the internet, like face forensic dataset, celeb dataset. So models are well saying, but the model doesn't work on low quality videos and may struggle if the face is turned at a certain angle. And some models have a overfitting and underfitting problem. So I found these some limitations uh, in models. So my objective is to review existing works in defect detection and identify gaps, then propose a methodology for defect detection, then to implement this proposed methodology and compare the performance with the previous ones. So I used this Python as a tech stack, and I used the real and fake defect detection data set from Yonsei University's Computational Intelligence Labs, and it contains 2041 images, and it is a labeled data set of real and fake deepfake images. So this is my the detailed flow of from data collection to the model evaluation. First is a data collection, then is a I done a data pre-processing. In that data pre-processing, I done some basic steps: caching, shuffling, prefetching, data augmentation to to take the diversity of the data set, then splitted the data set 80% for training, 10% for testing, and 10% for validation. So after that, for feature extraction, I have used the three different models, and I done the new hybrid model for the this study. One is the mobile net with two vision transformer and efficient net. So this is the my detailed architecture. First, on raw image, I done batching, shuffling, catching, prefetching steps, and after this process, the image is passed through the my system architecture. So first off, I taken the MobileNet V2, EfficientNet V7 and Vision Transformer. Basically, MobileNet V2 and EfficientNet V7 is the recent CNN models, and Transform Vision Transformer is a transformer model. So it is the competitor to the CNN. So that's why I taken the all three models and passed the my image through that. I got the different numbers of features. So after that, I added this all feature sets and passed it through the three dense layer to learn well the model. And after that, here is the some after dense layer. Here are some hidden layers like a dropout layer to minimize the to generalize well the model. So and lastly, I passed this to the softmax activation function, and it gives me the probability of real and fake deepfake detection. So this is the step-wise approach to the solution: data loading, preprocessing, augmentation, data splitting, model creation, and model training. So this is the implementation results. First is the model accuracy and model loss. Here you can see that the model loss is gradually decreasing. That means the model is not overfitting. Model is well structured and more reliable than the existing ones. These are the implementation screenshots. So I achieved the accuracy of 94.64%, and throughout the singing. So I used this. My model is the hybrid model, and this gives the better accuracy than the individual models. Also, I compared my study with the existing ones. So this is the recent studies that uses the same data set for the defect detection, and I am also using the same data set. So it can see that the my base paper is the first one, Rafiq. So defect detection and classification using error level analysis and deep learning. So it given the 89.5% accuracy, but our model gives 94.64% accuracy. So we can conclude that I taken the different three models and leveraging the strengths of all these models in our hybrid model. So it gives us the strong classification matrices, and it also gives us the diverse feature captures. Okay, so one of some feature work, some researcher can be done the feature work in my study, like optimize model further, then dataset, expand the dataset more, then different multimodal approaches like done researchers can do the take the different models and do the multimodal hybrid model. So it is the one of the feature scopes, and last is the cross dataset evolution. So these are the references I referred for my study. Thank you so much.
Thank you, Shubham. Very good presentation once again. And I just want to know, just like you said, you have used multi-model approach, right?
Yeah. Yes.
So I just missed which are the models you have used. I just missed that. Can you tell me which
Okay.
all the models you have went for?
I taken the MobileNet V2 model, ma'am, from CNN.
Hmm.
Second is the
Hmm.
EfficientNet B7, is a top
Hmm.
variant from
Hmm.
EfficientNet. And third one is
Hmm.
a Visual Transformer. It is a transformer model. So
Okay.
I taken these three models
So
and
why
I did,
these specific models only you have used? Any
yes,
reason
yes,
behind not key you went for these models?
yes. I taken my ma'am one base paper for my study, and
Hmm.
in I first implemented the base paper. In that base
Hmm.
paper, they implemented the ResNet 15 model. So I after implementing, I found that this model is far heavy than other models. So I taken the lightweight models like MobileNet V2 and trying to uh, outcomes. So that these models give better accuracy than this. That's why I taken this specific models. And EfficientNet B7 is the higher level model in CNN family. That's why I taken this one.
Okay. 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 Thank you. That is from my side. Thank you.
Thank you.
Thank you for your presentation, sir. Sir Shivam will be presenting one more paper on the title, Enhancing the Accuracy of Heart Disease through Hippopotamus Optimization Algorithm and Evaluation of Machine Learning Algorithm. So you can start
Okay.
presenting the screen. Yes, sir, your screen is visible.
Okay. So this is my second paper, improving the accuracy of heart disease prediction system using hippopotamus optimizer. So this is the contents of my presentation. So first of all, start with the introduction. So heart disease remains the one of the leading cause of death worldwide. So accurate system, we needed the accurate system for this role because this problem statement is falls under the healthcare domain. So that's why we need the more accurate and reliable system for the heart disease prediction. There are some major major systems of for the heart disease prediction is available and it gives better accuracy. But the sometimes it's not generalized well over the unseen data. So that's why we need a more a reliable system. So motivation, motivation behind that is to the previous models issues like overfitting, underfitting, and poor generalization. And I found that the hippopotamus optimization algorithm is the recent algorithm which is published in recent 6 months ago. So this is the basically nature-based optimization algorithm. So this can be with this algorithm which we can be used for the model optimization and the parameter tuning. So I thought that the one of the existing system is available on the internet that heart disease prediction using the principal component analysis. Simply I applied this approach over the uh, existing system. So my motivation behind that is to understand hippopotamus algorithm, to implement hippopotamus algorithm, and to evaluate the performance and compare the accuracy with traditional methods. So in the previous survey, I said that the previous models cannot be generalized well. So that's why I used my new approach for this study. So I use the Cleveland dataset available over the internet from UCI directory. It has the 303 records and the 14 columns, including target. So it has the labeled dataset. So first off, I collected the dataset from UCI directory, contain 13 features, then done the data pre-processing, some handle the missing values, then done the standardization and splitted the dataset 70% for training and 30% for testing. Then for feature selection, I use the principal component analysis. So it can be used for the dimensionality reduction and selected the top 9 features. So for hyperparameter optimization, use the hippopotamus optimization algorithm. Then after that, after extracting the features, the top 9 features out of 13, I applied the various 9 machine learning classification algorithm like logistic regressions, support vector machines, KNN to evaluate the performance. And basically, the hippopotamus optimization algorithm is a new optimization method inspired by the nature of the hippopotamus. So it basically the taken from the it is basically from the nature inspired algorithm and that uses the hippopotamus behavior like how it works. First is the exploration. So exploration means once a good feeding area is found for the hippos, so hippos exploit it until no longer beneficial. So and it next is a social interaction. So social interaction means moving in a space. So hippo moves from the one location to the another, search for the better areas. Similarly, the candidate solution are updated iteratively within the problem space. So and last is the iteration means hippos continuously repeat this search and feeding behavior. So in hippopotamus optimizers, the process loops over multiple generations to find the optimal solution. So this is the optimization algorithm. So this is the my system architecture, as I said. First is the data collection, then pre-processing, then feature selection, then top 9 principal components I found. And on that top 9 components, I applied the hippopotamus optimizers, then data splitting, and then evaluation on the basis of accuracy, sensitivity, specificity. So this is the my results. And this is the comparison tables with the existing system. So I found that the SVM, KNN, and tagging boosting these type of algorithms are give far better accuracy than the existing ones. So this is the our 9 feature sets out of 13. So it gives the 93.40 and 92.30% accuracy for SVM, KNN respectively. And without this optimizer, it will also give the 90.11 and 86.81% accuracy. So that's why I used this approach for my study. So thank you so much, ma'am. Hello,
Thank you for your presentation, sir. Do you have any question?
Hello.
hello, ma'am.
Yeah, once again, very good idea you have. You said that you have handled the data or you have
Yes,
pre-processed the data, right?
yes, ma'am.
So you have handled the missing values. So what do you
Yes.
did with those missing values? Like how you replaced with
I replaced with the mean, ma'am.
the mean? Why
Mm.
mean?
Because it
Is
is
it
the
mentioned
that
in the algorithm that you have to go for mean or did it on your own?
no, ma'am. Because it is the balanced data
Mhm.
set. That's why I
Mhm.
use it to the mean.
Okay.
Yes, ma'am.
And accuracy, you said it is better than the earlier methods, right?
Yes, yes, ma'am.
So have they used the same data set? That is why you are saying that your
Yes,
accuracy
yes,
was far better
yes,
than
ma'am.
other one.
Yes,
Okay.
ma'am. These are the my basically base paper. SF1 is the selected feature set 1. So in this base paper, all means all features, 10 means top 10 features, and 9 means top 9 features. So basically, the previous authors done the different sets, 13 set, 10 sets, and 9 feature sets. So basically, the author found that previous author found that the in 9 feature sets give the better accuracy. So that's why I only taken the top 9 features and compared with this. And this is the previous study. Also have done the same data set, man, Cleveland data set that I have used for my study.
Yes, okay. Good, good. Thank you from my side. Yeah.
Thank you for your presentation, sir. Now moving on to
Thank
our
you.
next presenter, I would like to call upon Sir Ganesh to present his paper on the title Explainable AI for Data Leakage Detection, Enhancing Trust in Deep Learning-Based Security System. Do we have you here with us, sir? Do we have anyone else from the team with us? Since there's no response, we will be moving forward with the next presenter. Next, I would like to call upon Sir Arnav Joshi to present his paper on the title Leveraging a Combined Machine Learning and Deep Learning Approach for Landslide Prediction. Do we have you here with us, sir?
Thank you. I hope I'm audible.
Yes, sir, you're audible.
Okay, I'll share my screen.
Sure, sir.
Is the screen visible?
Yes, sir.
Okay. So, good afternoon, respected session chair, esteemed delegates, and fellow researchers. I'm Arnav Joshi, presenting on behalf of my team and my mentor, Professor Priya Surana from Pimpri Chinchwad College of Engineering, Pune. So, our research focuses on the topic leveraging a hybrid machine learning and deep learning approach for highly accurate landslide prediction. So first of all, let's understand what is the problem. Landslides are among the most devastating natural disasters globally, impacting infrastructure, human lives, and economic stability. They possess high risk uh, all around the world, and with increasing rainfall intensity and land use changes that we notice over these days, particularly in the mountainous regions of India, the risk is rapidly increasing. So what makes the prediction challenging is the complex interaction between terrain, rainfall, geology, and vegetation, which the traditional models are often failing to capture effectively. So this motivated us to research and go beyond the single layer models and explore hybrid solutions that integrate the best of both machine learning and deep learning. So presenting our research objectives, first one was developing a hybrid model that fuses the strength of both machine learning and deep learning technique, improving prediction accuracy, leveraging satellite dataset via using Google Earth Engine, and to validate the model's accuracy and prediction across all the diverse terrains. Now moving on to the literature review. This table summarizes the overview of what all the literature we went across and what all machine learning and deep learning models we saw. So the machine learning models like random forest, SVM, logistic regression work on tabular type of data basically, and they learn from the labeled features using a rule-based logic. They perform well on structured data, but they lack deep spatial awareness. Whereas deep learning models like CNN, LSTM, transformers, and GNN performed well on imagery and sequences, basically unstructured data, and they are able to grasp the spatial and temporal patterns of the image and time series data effectively, which is an important factor in landslide prediction. So we can see the performance given below in the table. Random forest has given around highest accuracy of 95, SVM 94, 90, and logistic regression 95. But the problem with this was that they have only worked with structured data set. And performance of CNN also we can see they give around 90 to 91% of precision. Mask RCNN gives 0.97 of F score, F1 score, and a hybrid CNN LSTM gives about 92 to 95% of accuracy. So coming back to the proposed hybrid model, we have now seen the advantages and limitations of ML and DL. Advantages of machine learning is it handles structured data. It is less compute intensive, and it is fast in terms of training. But the limitations is that struggles with raw data and needs feature engineering. Whereas in case of deep learning, it automatically extracts features from the given images, like the spatial and the temporal features. So it is effective for image analysis and needs high precision on large data. The limitations is it requires large data sets, and we incur high computational costs. So a hybrid ML and DL model that combines the power of deep feature extraction of deep learning and interpretable classification of ML allows us to give a more effective and diverse solution to the landslide prediction. So this is the proposed hybrid model. Our novel model combines the, excuse me, sorry. Our hybrid architecture begins with a convolutional neural network, CNN, to automatically extract deep features from satellite images like vegetation cover, slope, patterns, and terrain texture. These features are then passed to a random forest or XGBoost classifier, which efficiently distinguishes between a predictable landslide and non-landslide area and gives a probability score. So let's now talk about the data set. Our data set comprises of multi-source geospatial data crucial for comprehensive landslide analysis. So we have taken our data set, mostly data sources include topography, slope, aspect, geology, land cover, precipitation, soil moisture, and seismic activity. These all consolidate to form the most important factors deciding about the predictability of the landslide in the given area. So topography covers factors like slope, aspect, elevation. Hydrology and meteorology cover factors like rainfall, soil moisture, and drainage. Land cover includes factors like vegetation index and land use types. And we have also considered seismic activity data, which is also an important factor. So these all were derived from the high resolution satellite imagery from Sentinel-2 and SRTM. So we have used Google Earth Engine here, which provides free real-time and historical satellite data. It automates collection of geospatial layers like NDVI, DEM, slope, and aspect, supports large scale and cloud-based processing, which is ideal for high resolution input. After knowing about our dataset, now we'll go to the pre-processing. So we have used various techniques for pre-processing our data, which we have accumulated with GE, Google Earth Engine, including noise removal, which eliminates cloud, shadow, and redundant pixels. Normalization, which helps us to rescale the inputs for the stability and stable performance of CNN. Spatial patching, which divides large raster images into smaller patches. Labeling, which is used to create binary masks so that the model, the output of deep learning could be easily given and learned by the machine learning model. And data augmentation to address class imbalance using transformations. So now this is the overview of factors that affect the prediction of landslide. So we have considered parameters like slope gradient, elevation, aspect, soil type, rainfall intensity, antecedent rainfall, vegetation cover, NDVI, land cover, and seismic activity. In the given table, we can see the mapped susceptibility also. Like, for example, if the slope gradient is greater than 30, then we can assume that it is a high risk area. If it is between 15 to 30 degrees, it is a moderate. And if it is less than 15, it is a low risk area. So the table provides us information about that. Now we'll go on with model training and evaluation. So on the left side, we can see an image which shows us about the brief architecture and how the model was trained. We have got pre-processed geospatial data with help of Google Earth Engine. Then we have extracted the spatial features with help of CNN, and feature vectors were created, which were given as input to classify the machine learning models XGBoost, which assigned the susceptibility level. And based on that, we are able to map landslide susceptibility. On the right side, we can see the performance, accuracy. So our hybrid model has achieved accuracy about 93.4%, precision of 91.7%, recall of 92.6%, F1 score of 92.1%, and ROC AUC score of 0.94. So results, if we compare standalone models like LR, logistic regression, random forest, CNN, and then our hybrid MADL model, then we can see that hybrid model has significantly outperformed because of its ability to combine both
Sir, this is a
extracting
gentle,
spatial features and
sir, this is a gentle reminder that 9 minutes have been completed.
okay. So this chart shows us a brief idea of results. These are the key findings: enhanced prediction accuracy, robust feature learning. Our model significantly improves the landslide susceptibility mapping accuracy. It is effective for extracting complex data features using geospatial data. It has addressed limitations like overfitting and imbalance. And it is a scalable approach because we have used Google Earth Engine, which is able to consider real-time data. So it gives a nice approach of scalability. These are the key findings. Thank you for your attention.
So very good topic that you have selected, because it is nowadays it is very much required to predict the landslide. The images that you have taken, like you know that there are various types of lands in India. Like some lands are very restrict in the case, like we don't have the same kind of land everywhere in India, right? So I just want to
Yeah.
know which data set you have used, which type of land was that?
Okay, so with the help of Google Earth Engine, we were able to cover regions of various types of lands. So we used around 20 to 25,000 of image patches, which were covering a lot of area like the Himalayan range, Uttarakhand belt, areas of Nepal, China, Japan. So we made sure that we are not using only a specific kind of area because that then affects the accuracy and training of the model. So we made sure that we are using a varied kind of data, the image patches that we were giving for training of our model.
So you mean to say your model will work for all kind of lands? Let
Yeah,
it be from Uttarakhand or Maharashtra or from South
because
region.
I guess that's the yes, ma'am. Because we have used the data like almost real-time data from the Google Earth Engine. It is able to work on different kinds of lands that we give, and it is giving kind of good accuracy with that too.
Okay. So very good attempt.
Yeah. Thank you,
Uh,
ma'am.
thank you from my side. Thank
Yeah.
you.
Thank you, ma'am.
Thank you for your presentation, sir.
Thank you so much.
Now moving on to our next presenter, I'd like to call upon Ma'am A. Punita to present a paper on the title Smart Malware Detection in IoT Devices Using Optimized Feature Engineering and Deep Neural Networks. Do we have you here with us, ma'am?
Yes, sir. Yes, sir.
Okay, ma'am. You may start presenting your screen, ma'am.
Yes. Is my screen visible, sir?
Yes, ma'am.
Yeah. Good afternoon, everyone. Myself, Punita, working as Assistant Professor in the Department of Artificial Intelligence and Data Science, KPR Institute of Engineering and Technology, Coimbatore. So I'm going to present my research title on the topic Smart Malware Detection in IoT Devices Using Optimized Feature Engineering and Deep Neural Networks. So the reason for choosing this topic is IoT is revolutionizing industries, but it also expanding the attack surfaces of cyber criminals. So the traditional signature-based methods can't keep up with evolving threats. Moreover, IoT devices have limited computing power, so we need efficient yet accurate detection mechanism. So our objective is to build a scalable, intelligent malware detection system by extracting behavioral data like API calls and permissions. We aim to train models that are both accurate and lightweight. So we also analyze various ML models to find out the most effective way to analyze the malware in a dynamic time. So the research has shown that traditional malware detection methods either lack adaptability or generate many false positives. Machine languages, especially deep learning, shows promise, but it must be paired with strong feature engineering to truly effective to find out the malwares. So in our framework is modular. It begins with collecting executing logs from the IoT applications, followed by the feature extraction and optimization. We then train and evaluate models to classify the application as binning or malicious. But the optimizing the feature set. So we engineered features from three behavioral categories. So principal component analysis, PCA, helps us reduce dimensionality while retaining variance, and recursive feature elimination, RFE, further filtered features to keep only the most informative ones, ensuring high performance with low overhead. So the models used for classification is we train three types of models to classify the malware or rootkits. So the random forest and support vector machine are widely used, but we focused on deep neural networks due to their adaptability to learn complex patterns. These were implemented using Python libraries that such as TensorFlow and Scikit-learn. So these are our performance comparison. The DNN model outperformed both a random forest and support vector machine across all matrices. It achieved nearly 96.1% accuracy and the highest recall, which is crucial in cybersecurity to avoid missing actual threats. So these results variate our approach, combining DNN with optimized features so that the dynamic malware prediction or the rootkit can be highly accurate. So the thing which we achieved is our contribution include highly accurate and efficient malware detection framework, which optimized for the limitations of IoT devices. The combination of feature engineering and DNN modeling provides both robustness and scalability. In conclusion, we have demonstrated a practical approach to smart malware detection. Our future work will focus on real world deployments, privacy preserving models like federated learning, and exploring ultra weight models for on device interface. Thank you.
Thank you for your presentation, ma'am. Are there any questions?
Yes, no questions from my side.
Yes, ma'am. Thank you.
Moving on to the next presenter.
இது கூட
I would like to call upon Sir Jolu Winsett to present his paper on the title, The Influence of Artificial Intelligence on Higher Education in the Philippines. Do we have you here with us, sir?
Good evening, everyone from Philippines. In behalf of our Vice President, I would like to present our paper entitled The Influence of Artificial Intelligence in the Philippines. Please give me a moment. I will be sharing my screen.
Okay, sir.
So I'm here to present our study entitled The Influence of Artificial Intelligence on Higher Education in the Philippines. In behalf of the Vice President of City Colleges for El Salvador, Dr. Jolo Hala, I'm here to present the paper entitled The Influence of Artificial Intelligence on Higher Education in the Philippines. And our co-presenters are Evelyn Nakalaban, Nenon Roy Sandiano, Ryan Boyd Origines, and Batyon Nelson. By the way, my name is Randy Joy Magno Bentayan. I am from Pangasinan State University of the Philippines. Artificial intelligence is no longer a futuristic concept. It's actively reshaping the industries worldwide, and higher education is profoundly impacted. In the Philippines, this influence is particularly dynamic and inspiring. Our study will look into this transformation, recognizing that integration of AI requires a deep understanding of our unique technological, economic, and educational landscape. And we aim to uncover both the exciting benefits of artificial intelligence offers and the significant hurdles we must overcome to build an equitable and successful AI-driven future for Philippine higher education sector. The objective of this study is to thoroughly explore and understand the influence of artificial intelligence on higher education. And the integration of AI is already redesigning our academic landscape, enhancing everything from teaching and research to administrative process. However, this journey isn't without its challenges. Many of our colleges and state universities grapple with limited funding, making it difficult to acquire and maintain advanced AI technologies. We also face a significant digital divide where students and faculty in remote areas often lack reliable internet and essential digital skills. Yet, despite these obstacles, AI offers immense opportunities to revolutionize education in our country. Our methodology to conduct this research, we employed a narrative literature analysis, drawing upon the established framework by Gann and Both from 2009, and this systematic approach allowed us to thoroughly review existing publications on AI in higher education, carefully selecting high-quality articles and synthesizing their findings. It's about building a coherent understanding from diverse studies, interpreting their contributions to form a comprehensive picture. And our systematic search began broadly identifying the large pool of Scopus index articles. From there, we narrowed down our focus, exploring specific themes where AI intersect with higher education. And we use the Prisma diagram. The Prisma diagram visually illustrates the rigorous selection process we followed from initial intensive pool of articles. We systematically screen them for quality and relevance. This careful filtering ensured that our final analysis was based on a robust set of studies, providing a strong foundation of our findings. So let's now proceed to the key result, the application of artificial intelligence in higher education. Our findings highlight several key implications and applications of AI in Philippine higher education. As depicted in Figure 2, AI holds immense potential, or personalized learning allow us to tailor educational experiences even in large class sizes. It can significantly improve access to quality education, particularly for students in rural areas through virtual platforms. AI also plays a crucial role in solving job skills mismatch by aligning academic programs with industry demand. And it can modernize administrative procedures, making tasks like admissions and grading more efficient. And it empowers innovation and research by helping scholars tackle complex problems more effectively. However, embracing AI comes with own challenges. We identified significant hurdles related to digital literacy and infrastructure, as well as the social and ethical implications of AI. There are also inherent resistance to change and the need for robust faculty development programs. And looking deeper into the ethical considerations, we must address critical areas like security and data privacy, ensuring fairness and mitigating algorithm bias, bridging the digital divide, and establishing clear guidelines for human supervision accountability. We also need to consider student autonomy and consent, and the evolving roles of staff and faculty, and safeguarding intellectual property and academic integrity. In conclusion, the AI presents an enormous opportunity to transform Philippine education. It can bridge existing access gaps, significantly enhance learning outcomes, and foster a culture of innovation. Achieving the transformation demands a truly holistic and collaborative approach, bridging together educational institutions, government agencies, and technology providers by proactively addressing ethical concern, technological iniquities, and digital gaps. In the Philippine education system can truly harness AI power to build an equitable, dynamic, and exclusive future for all. And for the implications to ensure that AI ethical and successful integration, we propose several key recommendations. First, the develop of national AI framework for for higher education with the clear guidelines for adoption of ethics and data privacy. And we have also the raise private and government sector investment in artificial infrastructure. And the third one is incorporate artificial intelligence training in faculty development programs. Next one is to foster AI-driven inclusive education, administer comparative studies and research and artificial intelligence adoption in education, and ensure ethical artificial intelligence deployment and address cultural resistance. So as to path forward for AI integration in the Philippine higher education, it requires a strategic and exclusive mindset. It means fostering strong collaborations between academia, industry, and policymakers to establish ethical framework and invest in capacity building, prioritizing equitable access to AI tools and digital infrastructure, especially in underserved areas, is paramount to bridging the digital divide. And continuous evaluation and feedback mechanism will ensure that AI technologies is truly aligned with our educational goals and promoting innovation while upholding academic integrity and equity for all. So for those interested in getting deeper, a comprehensive list of reference is included in this study. And would like to thank once again for your time and attention. And would like to thank you to all the committee and members of the 10th edition for ICT4SD International ICT Summit and Awards. Thank you very much and congratulations to all presenters.
Thank you for your presentation, sir. Do we have any questions?
Yes, very nice topic that you have chosen, because we need to identify how AI is going everywhere in all corner of the world, and how it has been done in the Philippines as well. And definitely you said that there are faculty development programs, you said that need to be there. So we do organize and we'll stay in connect with you regarding the various faculty development programs if we organize, and hope to remain in connect regarding the growth of AI. So yeah, that is from my side, Ajay. Yeah.
Thank you very much, Dr. Juan Hale.
Yeah. Thank you. Yeah.
Thank you, sir. Now moving on to our next presenter, I would like to call upon Ma'am Vishini to present her paper on the title, The Role of Marketing Mix Elements and Personalization on the Brand Equity of Online Fashion Retailers. Do we have you here with us, ma'am?
Yes, I'm here. And am I audible?
Yes, ma'am, you're audible.
I'll share my screen.
Sure, ma'am.
I hope my presentation is visible.
Yes, ma'am.
Okay, so good evening, everyone. I'm Vishani, and I'll be presenting a research titled The Role of Marketing Mix Elements and Personalization on the Brand Equity of Online Fashion Retailers. This paper was co-authored with Kishan Raj and Samyukta Vimal. We are students from Amrita School of Business, Kochi. The online fashion retail sector in India is experiencing remarkable growth. It is projected to surpass $30 billion by 2025. But with this rapid growth comes evolving consumer expectations. Consumers expect more than just low prices or good products, they seek personalized experiences. Traditionally, the 7 P's marketing model served as the foundation for retail strategies, but it needs to adapt to the digital era. Personalization is becoming a key differentiator, and brand equity in this context refers to the value a brand holds in the minds of consumers, driven by their perceptions, trust, and experiences. This research will help online fashion retailers, particularly startups, to identify the most impactful marketing elements and optimize strategies that enhance brand equity and customer loyalty in the digital age. In the study, our key objectives are to study how the 7 P's of marketing mix and personalization affect brand equity in the online fashion retail, explore the relationship to perceived value, brand loyalty, involvement, trust, commitment, and repurchase intention, address gaps in previous studies by analyzing how these marketing elements work together to build brand equity, provide insights useful for marketing practitioners, e-commerce strategists, and brand managers. Finally, recommend strategic actions for fashion retailers based on consumer behavior trends in digital first shopping. To meet our objectives, we frame two guiding research questions. How do the 7 P's of marketing mix, that is product, place, price, promotion, people, physical evidence, and process, impact the brand equity of online fashion retailer? And how does personalization impact the brand equity of online fashion retailers? Our research adopted a quantitative approach with a sample of 200 online fashion consumers. The sampling method used was convenience sampling. We collected responses through a structured questionnaire that covered demographic details and 7 P constructs, personalization, and brand equity dimensions. The responses were recorded using a 5-point Likert scale. The constructs were adopted from validated academic scales. Finally, we used SPSS for analysis. Based on our literature review and our research question, we proposed 8 hypotheses, each corresponding to a component of the 7 P's plus one for personalization. These hypotheses explored whether each element has a significant effect on brand equity within the online fashion retail context. Let's now look into the analysis and result of our study. In terms of data validation, we checked for common method bias using principal component analysis. The first component explained 39.3% of the variance below the 50% threshold, indicating the common method bias is not an issue. And for reliability, the Crowbank's alpha is 0.969, demonstrating excellent internal consistency. To address multicollinearity, all variables had tolerance values above 0.1 and variance inflation factor, that is VIF value, below 10, confirming no concern. These data collectively validated the robustness of our data. Our regression analysis revealed a strong model fit with R value of 0.807 and R square of 0.651, indicating 65.1% variance in brand equity is explained by independent variables, and the adjusted R square was 0.623, confirming that the model is stable and reliable. Among the key findings, personalization emerged as the most impactful factor with a beta value of 0.363, and place was next with a beta value of 0.251, likely due to its impact on delivery speed and accessibility. Though promotion had a positive effect with beta of 0.174, it was not statistically significant. And the remaining elements, product, price, people, process, and physical evidence, had limited influence in the context and were not significant predictors. These findings reveal a clear shift towards experience driven online shopping. Personalization, place, and promotion significantly influence brand equity. These insights are valuable for e commerce leaders and especially startups entering the fashion retail space. And understanding these dynamics helps firms optimize marketing spent on high impact activities. And based on our findings and implications, we have proposed the following recommendations. First, to prioritize personalization. This can be through AI, dynamic contact, and consumer data. Strengthen logistics delivery to improve reliability, enhance promotional strategies using influencers, UGC, that is user generated content, and loyalty programs. And last, instead of competing on price alone, focus on seamless experiences and brand trust. To conclude, personalization, place, promotion are key brand equity drivers, while the other 7 Ps provide support, but they have less direct influence. Strategic focus should shift towards consumer centric and experiences driven retailing. Ultimately, investing in personalization and delivery excellence helps brands and new startups build lasting loyalty and gain a competitive edge in digital fashion markets. And our reference includes seminar works who have extensively contributed to branding, service quality, and personalization literature. And thank you so much for everyone's attention.
Thank you for your presentation, ma'am. Are there any questions?
Yes, no questions from my side.
Thank you,
Okay,
ma'am.
ma'am. Moving on to our next presenter, I would like to call again Sir Ganesh to present this paper on the title Explainable AI for Data Leakage Detection, Enhancing Trust in Deep Learning-Based Security System. So we have you here with us, sir. Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the session. I sincerely thank our authors for the excellent presentation and contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support in this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificate through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. I also thank the session chair, Dr. Kirti Vanjale, for sharing this session. I would now like to request ma'am to share her thoughts and any feedback about the presentation of the session. Over to you, ma'am.
Yes, as usual, the ICT team has performed very good, and I have attended few conferences before as well. The team has performed great, and regarding participants, I can touch upon the various topics or various what I'll say the state of the art topics throughout these all papers that I have listened right now, and I'm finding that there is a very great future to for India to go in the field of AI, IoT, cybersecurity, blockchain, because all papers were diversified with all these domains, and that is very good to hear of all papers. And congratulations to all authors and as well as the team ICT for very good conduction of this conference. Thank you.
Thank you, ma'am. Here's a token of appreciation to the chair on behalf of Team ICT4SD 2025 and Global Knowledge Research Foundation and partners. Thank you everyone for your valuable presence. Just before we end the session, I kindly request you to switch on your camera for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe. Take care.